4, sections 4.1 to 4.3. Okay, this is what I'm going to cover in detail. The first thing we're going to cover is exponent properties, converting radical expressions to exponential expressions and vice versa, simplifying radicals, exponential functions. We need to graph them, writing exponential equations into logarithmic equations and vice versa, graphing logarithmic functions, and application problems. So let's start with some of the properties. Okay, it says here, if m, n, and p are integers and a and b are real numbers, then the properties are going to hold. For example, this is called the product property. If you have a to the m times a to the n, we can add the exponents. It'll be a to the n plus n. And all these rules are rules that students should have known by now from high school. Or maybe if they're taking the NCBA 0324, it's going to help them out with that course. And for 1324, they don't really go over these like in detail. Why? Because they assume, the author assumes that you guys should know this by now. But anyway, I'm going to go over them, regardless if you know them or not. Okay, this way you guys can be familiar with these rules. Rule number 2 is called the quotient rule. The quotient rule, if you have a to the m divided by a to the n, then it equals to a to the n minus n. And a cannot be 0 because if a is 0, it'll be undefined. And this is called the power rule. If you have a to the m raised to the power of, a to the m raised to the power of n, we multiply the powers. Now this is called the power of the product property. If you have a times b to the n, it'll be a to the n times b to the n. And furthermore, if you have a to the m times b to the n, right, you're going to multiply the a, it'll be a to the power of m times p, and b to the power of n times p. Same thing with the division for the quotient. If you have a divided by b to the power of n, it's going to be a to the n divided by b to the n. I'm going to show you examples of each one of these, okay? But let me finish all the rules first. And also, furthermore, if you have a to the m divided by b to the n raised to the p power, you're going to multiply the p times the exponent. So it's going to be a to the m times p and b to the n times p. This is called the negative exponent rule. If you have a to the negative n, you make it positive by sending it to the bottom, and the exponent becomes positive. So it'll be 1 over a to the n. Or also, it can also be the reciprocal. You see, here's a reciprocal. If you have a fraction, like say a divided by b to the power of negative n, you do the reciprocal or you flip the fraction, and the exponent becomes positive. This is called the zero exponent rule. If you have a to the 0 is equal to 1. Anything to the 0 power will always be 1. But a cannot be 0. Okay. This is a fractional exponent. So you're going to go from a fraction right to a radical and vice versa. This is crucial for the students that are going to be taking 1325, which if you're majoring in business or accounting, you have to know these rules here. Most of these rules. Okay, now let's do examples of each one. Example, this is called the product rule. If you have a to the m times a to the n, it will be a to the n plus n. The a is going to be the base, and the n is going to be the exponent. Must have the same base to apply the rule. Example, you have x cubed times x squared. Here, guys, I use color code. That way you know exactly what's taking place, but this is doing it the long way. For example, you have x cubed, right? It'll be x times x times x. That's why I put it in blue. Times x squared, right? It's going to be times x times x. That's going to put it in green. So x times x times x times x times x 5 times will be x to the 5th power. Okay, but it's easier by applying the rule. If you have x cubed times x squared, you add the exponent. So it'll be x to the 3 plus 2. But eventually, guys, this can be done very quick, right? So right away, we know these two are the same base. So all we do is add the exponents, so we can go straight to the answer, which will be x to the 5th power. Number 2, x to the 7th times x cubed, right? They have the same base. So we can apply the rule. So it'll be 7x to the 10th power. Number 3, x squared times y to the 4th power. These are not the same base, so the rule cannot be applied. So the answer just stays how it is, x squared times y squared. Look at number 4. You have 5x to the 4th times negative 3x squared. So first we can multiply the coefficient for 5 times negative 3 is negative 15. And then we can add the powers. So this is how we do the work, right? But you can go straight to the answer. The answer should be negative 15x to the 6th. Okay, how about this one here? What's negative 3 times negative 3 is going to give us 6, right? And then we have x and x, so we're going to add the exponents for the x's. We're going to add the exponents for the y's. So they will give us 6, x to the 9th, y to the 5th. Number 6, negative 5 times 6 will give us negative 30. X times x to the 3rd will give us x to the 4th, and y cubed. So this is my result for number 6. Negative 30, x to the 4th, y cubed. Now this one here, right? We have 3 times 8 is going to be 24. X to the 4th times x to the 5th will give us x to the 9th. And y cubed times y will give us y to the 4th. So this is my result. Okay, so now let's move on to the next rule. This is called the quotient rule. Okay, now, if you have x to the 5th divided by x squared, right? They have the same base, so we can apply the rule. It'll be x to the 5 minus 2 will give us x to the 3rd power. Number 9, x to the 10th divided by x to the 7th, they're the same base, so it's going to be x cubed. Number 10, x to the 4th divided by x to the 8th, right? It's going to give us x to the 4 minus 8 will give us negative 4. Now this can be reduced, right? But I haven't covered the negative exponent rule yet. Okay, that's rule number 6. Okay, so we'll wait and do it later. Now this is like the power rule, right? When you have a power raised to a power, if you have a to the m raised to the n power equals to a to the m times n. So here, guys, right, we have x cubed times x cubed raised to the 2nd power. Well, let me show you why it's better to use a rule, okay? Because x cubed squared is the same thing as x cubed times x cubed, right? Which is the same thing as x times x times x and x times x times x, which will give us x to the 6th power. But by applying the rule, it'll just be x to the 3rd squared will give us x to the 6th power. Okay. Here, I just showed you what's taking place, right? There's different ways to get the answer. But the most important thing is for you to get the correct answer. And in my opinion, by using the rules, by using these rules here, you can get the answer quicker. Okay. Number 12, negative x to the 4th, right? Raised to the 2nd power. This is going to give you positive. Why? Because a negative to the 2nd power to the even power is going to be positive. So it's going to give us x to the 8th power. And this is how. Negative x fourth to the 2nd power is the same thing as negative x to the 4th times negative x to the 4th. Right? This will give us x to the 8th power. And then look at this one here. Right? We have a negative y squared raised to that 3rd power. And there's going to be something to the 6th power, right? Because we can multiply the exponents. But is the y going to be positive or negative? If you notice, if we do a negative to the odd power, the answer is going to be negative. So it's going to be negative y to the 6th. But here's why. Here's how. Negative y squared raised to the 3rd power is the same thing as negative y squared times negative y squared. That gives us y to the 4th power. And then you multiply it by another one that's going to give us negative y to the 6th power. Okay. Now let's do another rule here. This is the power of a product rule and power of a quotient rule. So here's a rule. If you have ab to the nth power is equal to a to the n times b to the n. Example, number 14. We have x times y squared will be x squared times y squared. Okay, now number 15. We have 2x cubed. This is going to give us it'll be 2 cubed times x cubed. This will give us 8x cubed. Number 16. We have parentheses x to the third power, y to the fourth power, raised to the second power. So it's going to give us x to the 3 times 2. Right? It'll be x to the 3 times 2 and y to the 4 times 2. That's why it's x to the 6 times y to the 8th. Because again, we multiply the powers. Okay, now, number 17. Okay, we know, right, if it's negative and it's with the odd power, it's going to give us a negative answer. So this will give us negative 3 cubed, will give us negative 27. We have x squared, right? X squared times 3 will give us x to the 6. And y to the first power times 3 will give us y to the third power. This is my result. Anyway, here's how. Right? We can do it 3 times. Because negative 3 times negative 3 times negative 3 will give us negative 27. X squared times x squared times x squared will give us x to the 6. And y times y times y will give us y to the third power. Right? Or you can do it this, right, by applying the rule. Right? Separate each one. That will give 27. I get 27, x to the 6. And y to the third power. Like I said, there's different ways to get the answer, guys, okay? The important thing is for you to get it correct. But here I'm showing you different ways. That way there's no wrong way as long as the correct answer is found. Now comes number 5, the power of a quotient rule. Okay, here's where you have, if you have a divided by b to the nth power, it'll be a to the nth divided by b to the n. Example number 18. This will give us x cubed divided by y cubed. Number 19, right? So it'll be x to the 10th power because x to the 2 times 5 divided by w to the 3 times 5. So it's going to give us x to the 10th divided by w to the 15th. Now comes the negative exponent rule. If you have a to a negative n equals to 1, let's see, Paulina, you had a question, right? Let me see if I can answer your question, Paulina. Let me go back here and see if I can answer it. That's why I have 2 computers because on one I can check the answers. It says Paulina Perez says, I have a question. What if the power of the quotient rule has a multiple terms, and those terms also have negative exponents? Well then, but to answer your questions, if you multiply, right, if you have a power raised to a power, you multiply the powers. So if you have 2 negative powers, like a negative power raised to a negative power, it'll become a positive power because negative times negative will give you a positive. Paulina, did I answer your question? Paulina, if you want, wait afterwards, and maybe I can help you with that question. I can see if I can do it on the whiteboard or something. But right now, I cannot do that because I'm sharing my screen. And when I'm sharing my screen, I cannot go anywhere else. Okay, that's why I have 2 computers. On one computer, I see who has any questions, and on the other one, the one that I'm sharing is the one that I'm sharing my screen. Okay. Okay, now we have x to the negative 5th power, right? So here, guys, is going to be, right, by using the rule, it's going to be 1 over x to the 5th power by applying the negative exponent rule. Another example, 3 to a negative 2 is going to give us 1 over 3 squared, which will give us 1 over 9. Number 22. And number 22, guys, also, guys, when you have like a fraction raised to a negative exponent, what you do is you flip the fraction, right, or use the reciprocal and make it positive. That's a rule. Then it will give us y cubed divided by x cubed. Here's how, right? By applying the rule, right? It's going to be 1 over x divided by y cubed. When you have 1 divided by a fraction, right? So it'll be 1 times you flip the fraction, right? And then it becomes positive, right? This is equal to, 1 over 1 divided by x divided by y to the third power is equal to this right here, right? So it's equal to 1 times y divided by x to the third power. And 1 times anything will give you anything, which is y divided by x to the third power. Right? But it's easier to apply the rule. If you have a power, if you have a fraction raised to a negative power, what you do is do the reciprocal and it becomes positive. Example in this one, right? We have a fraction, so we do the reciprocal, and to the second power, so it's going to give us 5 squared divided by 2 squared will give us 25 over 4. Now let's do the zero exponent rule. Anything to a 0 power will give you 1. For example, a to a 0 is equal to 1. X to a 0 is equal to 1. Parentheses, x, 5xyz to a 0 power is also equal to 1. Okay? Now here comes the fractional exponent rule. Here's a rule, right? If you have a, the base a, to the power of m divided by n, hey guys, the denominator of the fraction of the exponent is called the index, which will be like the nth root. And then the numerator of the power of the exponent becomes a power on the radical. So this is these three. This one is equal to the middle one, but it's easier to use this one here. The last one. And right now, I believe I'm going to show you an example why. Okay. N is called the index. A is a radicand, which is a base, and m is the exponent, which is a numerator. And that's a radical symbol. Okay. Okay, now. X to the 1/3 power, right? So they want you to go from exponential to a radical. This is going to be the cube root of x. Because remember, the denominator of the exponent is the index. And x, right? And the 1, we don't have to put the 1 there because we know that x to the 1 power will just be x. How about this one here? Right, it's going to give us the 5th root of x cubed by applying the rule. Hey guys, this is crucial if you're taking the Math 1325. If you're going for accounting or for business, you have to know these rules. These are must. Because if not, you're going to struggle when you get to that course. Okay, I'm not trying to scare you, but I'm just trying to tell you how it is. Okay, so you have to know, or you can download this PowerPoint for your reference when you do take that course if you need to take it. And this way you can always refer back to this PowerPoint, and actually it will help you when you take the business calculus, which is a Math 1325. Okay, now look at this one here. The 3W guys is together, so that's going to be it's called a radicand. You see, it's together, so that's why it's going to be the cube root of 3W raised to the 2nd power. Okay. Now you're going to go the other way, right? They're going to give it to you in radicals, so you have to put it as exponential. So this, guys, right, since 8xw is together, that's going to be your base. That's your a. Your n is a 7, and the m is a 2. So it's going to be 8xy, that's your a, to the power of 2 divided by 7. Okay. Okay, now this one here is going to be, 6x to the power of 1/4. Because the 6x, right, is together and it's to the 1st power. Okay, now, here's a common mistake that students make. Let me show you the mistake that they do. These two are not the same. Okay? So a common mistake that students make, they say this is my answer. Let me show you why this is not the answer. Okay? Only the x is to the 1/4 power, not the 6. The 6 is not included. That's why, guys, you have to put this one here with parentheses because these two are not the same. That's why the parentheses are very, very crucial. Okay? Again, this is equal to this, and this is not the original problem, right? It's the fourth root of 6x. This is 6 times the fourth root of x. Okay, so please do not make that mistake. Okay, here. Hey guys, to simplify radicals, you need to know basic roots, such as square roots, cube roots, and fourth roots. So for the basic square roots, you have to know, right, the square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. So at least know all the way to about 10. At least know to 10. If you know more, I mean, it'll be better for you, but at least know all the way to 10. For the cube roots, right? For example, the cube root of 1 is equal to 1. The cube root of 8 is equal to 2. The cube root of 27 is equal to 3. And the cube root of 64 is equal to 4. Maybe one more. The cube root of 125 is equal to 5. So for the cube roots, at least know all the way to 5. Okay? For the fourth roots, the fourth root of 1 is equal to 1. At least, I mean, here, guys, at least know the 3, I think. The fourth root of 16 is equal to 2. And the fourth root of 81 is equal to 3. So at least know all the way to 3. Okay, these are the ones that you should know at least the cube roots all the way to 5 and the fourth roots all the way to 3. Okay, now, why is this important? Example of simplifying a radical. Okay, so you have the square root of 24. Is 24 a perfect square? No, it's not, right? Because 24 should be between 4 and 5. So then you have to simplify it. And eventually, guys, when you take the business math, I mean the 1325 course, there's a lot of these in that course that you have to simplify it. Okay. So, for example, how do we do that? Since 24 is not a perfect square, I need to get the factors of 24. Right? It's not a perfect square. 24, right? So it's going to be 1 times 24, 2 times 12, 3 times 8. And 4 times 6. Hey guys, from all these combinations, because we cannot use 1 times 24, we have to use any other one, right? So for example, what's the highest perfect square? The answer will be 4. So this is a combination that I'm going to be using. The 4 and the 6. Right? That's the highest perfect square is 4. So this is a combo I'll be using. This is going to be the square root of 4 times the square root of 6, which equals to the square root of 4 times the square root of 6. The square root of 4 is 2. So it's going to give us 2 square root of 6. That's how you simplify it. Okay? That's why you have to know perfect squares. So that's the answer simplified. Okay, now we're going to do exponential functions. Now we're done with the NCBN course, right? Like what you need to know. Those rules, some of the rules are going to prepare you for this portion here is for the 1324 class. But those rules are going to prepare you for this class here. Okay, so let's see how to use them. So for exponential functions, right? If you have 2 to the power of x, okay, they want you to okay, these are examples of exponential functions. If you notice, the exponent is going to be a variable, which most of the times is going to be an x, but it can be any letter, as long as the letter is the exponent, or the variable is an exponent, is called an exponential function. You see how these are examples. Okay, now you remember, recall, right? So this will be f of x equals to a to the x power. The fraction mn can be the same thing as x, because you can have also exponents that have fractions on them. Again, a is a base, like a quick review. The exponent is a variable, which is a letter. Right, so that's my function right there. And a has to be more than 0, because if a is 1, right? If a is 1, it will always be 1, because 1 to any power will always give you 1. That's why it has to be positive. Okay, and it has to be more than also. Okay, now let's see here. If we have f of x equals 2 to the x power. So here they want us to evaluate it, right? So they want us to graph it. These are the values that you have to use that are most commonly used. You always use from -2 to 3, okay? And right now I'm going to, they want us to graph this one. So we can do ourselves a little table, right? The f of x is the same thing as y. Okay, so now let's start when x equals -2. All right, so I'm going to go to my function, and I'm going to plug in -2 where the x is, right? So by applying the rule, guys, right, 2 to a -2 is equal to 1 over 2 squared, which is equal to 1/4. So when x is -2, y is 1/4. When x is -1, we evaluate it at f of -1, which will be 2 to a -1 power, which will be 1 over 2 to the first power, will give us 1/2. So when x is 1/2, when x is 1, -1, y is 1/2. Now this put 0, right? Now when x is 0, we're going to evaluate the function at 0. So f of 0 is equal to 2 to the 0 power, which will give us 1. Right here, we're applying the rules, the negative exponent and the 0 property. So when x is 0, y is 1. Now when x is 1, when x is 2, y is going to be 4. When x is 3, y is going to be 8, because 2 cubed is equal to 8. Now, right, we got our points, and this is my graph. You see, let me show you here, guys, right, where the arrow is. When x is -2, right, y is 1/4, which means I'm going to divide this unit here, right, this unit, this 1, into 4 equal parts. That's why it's going to give us 1/4 will be about here. Because imagine it would use -3. If we use -3, it's going to give us 2 to a -3 power, which will give us 1 over 2 cubed, which will give us 1/8. Because 1/8 at 3 is going to be real close to the x-axis. That's why it's useless to use any other power less than -2. That's the reason why these are the points that we always use. Because eventually, the more that we go toward the negative sign, to the negative infinity, the graph is going to get closer and closer and closer to the x-axis, but it will never reach it. But eventually, if we keep going right closer and closer to the x-axis, it's going to seem that it touches it, but in reality, it doesn't. That's why we only use points like from negative, at most -3 all the way to 3. Those are the points that are commonly used. Okay, now here's another graph of exponential functions. Okay, now this is exponential, right? So this is called growth, exponential growth. If you notice, the graph starts low and it begins to get high real quick. Okay, and these are the characteristics. The graph is above the x-axis. The y-intercept is 1. The graph climbs steeply to the right. The negative x-axis is a horizontal asymptote. The larger the base A, the more steeply the graph rises to the right. So for example, the bigger the A, the more the graph goes this way to the right. See, there it is. This is y equals to 2 to the x power in green. If you notice, the base gets bigger, right? So the base gets bigger, it begins to get closer and closer to the y-axis. That's what it means by number 5. The larger the base A, the more steeply the graph rises to the right. Okay, now, what happens when A is between 0 and 1? Right, so this is called decay, exponential decay. And these are the characteristics, right? But it's almost the same thing as exponential growth, but it's just in reverse, right? Because for the decay, it starts high and it begins getting closer and closer to 0 towards the right of the origin. Okay. And like it says here, the graph is above the x-axis, right? It's above. The y-intercept is 1. The graph falls sharply to the right. The positive x-axis is the horizontal asymptotes. The smaller the base, the more steeply the graph falls to the right. And there's my graph. Okay. Now, exponential functions continue. So what happens if they tell you to graph g of x equals to 2 to the negative x power? Right, so 2 to the negative x power is equal to 1 over 2 to the x, which is equal to 1/2 to the x power. All these three are equal. So again, we're using the rules that we learned, right, or the properties that we learned about the exponent, about the negative exponent, and also some of the rules that I went over at the beginning. So now, how do we graph this one? The same way, right? We're going to pick values from -3 to 3 for the x value, and then we plug them into the function. For example, here, right, if f is -3, we're going to plug in -3 for the x. Remember, guys, we use a reciprocal because the exponent is negative. We're going to use a reciprocal and make it positive. That way equals to 8. Right, and then we put -2, right? It's going to give. We're going to repeat the process. If it's -2, it'll be 1/2 to a negative second power, right? We use a reciprocal. It becomes positive. It'll be a 2, and then it's going to give us 4. So if I repeat the process, guys, this is a graph, how the graph is going to look like. Okay. Now comes logarithms. I believe logarithms are in 4.3. Okay, to begin the logarithms. Okay, now onto the development of computers and calculators, logarithms were the only effective tool for a large-scale numerical computation. But this is no longer needed because we have calculators and computers. Okay. This is a definition of logarithms to a common base 10. For example, if you have y equals to log of base 10 to the x, is the same thing as y equals to log of x, right? Because we know if there's no base, we know it's 10. This means that 10 to the y power equals to x. Okay, this is how you go from log to exponential, which I'm going to show you right now. You see, no base is base 10. Okay, simplifying logarithm without a calculator. If we have log of x or log of base 10 to the x power, right? This is how you read it. To what exponent must 10 be raised to give you x? Example, right? So to what exponent, right? To what exponent should we raise 10 to give me 100? The answer is 2. This is what this means in words, right? To what exponent must 10 be raised to get you x? So this is really what it means. Okay, now again, to what exponent will 10? To what exponent will 10 be to give us 1,000? 10,000. So the answer is going to be 4. Why? Because 10 to the 4th power gives you 10,000. Okay, now this is a different base. This is base 7. So here, guys, it says 7 to what power will give me 49? Right? The answer is 2. Because 7 squared, it gives us 49. We're going to look at this one. So it's going to give us 3 to what power will give me 27? The answer is going to be 3. Okay, now we're going to be writing exponential equations into logarithmic equations and vice versa. Because this is a definition. I know that I went kind of briefly towards this, but that was the most important thing that you got to know for the logarithms at that time. And then later, guys, I'm going to show you how to put them in the calculator. Okay, again, if you have y equals to log of a to the x, it means a to the y equals x. I believe in my class, I like to use b instead of a, because for me, the b stands for base. Okay, but I'm following how the author in this book, in the 13th edition, what he uses for the symbols and for the letters. So I keep it the same way. But for my class, I like to use b instead of a. Okay, it says here, write logarithmic equation into an exponential equation. Okay, so you have to go from log to exponential. If you notice, guys, you have to know what the a is, what the x is, and what the y is. Right. So in this case, my a is 9. My x is 81, and my y is 2. Now I'm going to write it in exponential form, right? So my a is 9, my y is 2, and my x is 81. That's your result. Okay, now let's do another one. Okay, now guys, we're going to go the other way. Okay, they're going to give you, we're going to go from exponential to logarithmic. I should have done more examples, right? But I only did one because this is kind of easy to follow. Just follow. This is what how you go from logarithmic to exponential. So what you have to know is know the a, the x, and the y, and just plug them in where they belong. Now we're going to go the other way. 5 cubed equals to 125, right? So here, guys, my a is 5. My a will be 5. My x will be 125, and my y will be 3. Now I'll go here to the log equation. Right, so my y is 3, my base is 5, and my x is 125. So 5 to the third power equals to 125 is equivalent to 3 equals to log of base 5 of 125, or log of 5 of 125 equals 3. These two are the same thing. Okay. Now comes the logarithmic functions. Okay, so this is a logarithmic equation, and this is its equivalent exponential equation. So they want us to graph y equals to log a base 2 of x. So we have to convert it to exponential, right? So it's going to be 2 to the y power equals x. So again, what I put here, guys, in red on top, in order to graph without a calculator, you must convert the logarithmic equation into an exponential equation. So we just did that. So now we're going to do a table. You see, guys, but instead of plugging the values for x, we're going to plug them in for y. Okay, because y is my exponent. So if we do that, okay, it's going to give us 1/4, 1/2 when it's going to give us 1/4 when y is -2. It's going to give us 1/2 when y is -1. It's going to give us 1 when y is 0. It's going to give us 2 when y is 1. It's going to give us 4 when y is 2. And finally, it's going to give us 8 when y is 3. And here's my graph. But the blue is the exponential function, and my red is my logarithmic function. You see, if you notice, guys, let's see how we graph the logarithm, guys. Okay, when x is 1/4, 1/4 will be about here, right? 1/4, you're going to cut this unit here, the first unit, you're going to cut it into 4 equal parts. So right there's my half. So half of 1/2 will give it 1/4. So when x is 1/4, all we do is we come straight down, and the answer is -2. When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. And when x is 8, y is 3. This is my graphs, guys, right there. The blue is exponential from the beginning of the PowerPoint, and the red is a logarithmic graph. Now, here's how you apply them like in real life. Okay. First, this is an exponential function, right? Because you have a to the x equals to an exponent, right? The exponent is a variable. That's why it's an exponential function. It says the assets in billions of dollars for a prudential financial incorporation can be approximated by the function a of x equals to 315 e to the 0.056x, where x equals 7 corresponds to the year 2007. Find the assets for the following years, for the year 2000 and for the year 2012. So here's my solution. Okay, it tells us that x equals 7 corresponds to the year 2007. So then x equals 0 will correspond to the year 2000, and x equals 12 will correspond to the year 2012. So for part A, we're going to evaluate a of 0, which means we're going to plug in 0 for the x's. So the answer will be 315, right? So it's going to be 315 billion because the assets are in billions. Okay, now guys, it's wise to know that 315 is called my initial value. Why is that called my initial value? Because when time is 0, when x is 0, whatever the y is, that's your initial value. So the 315 is my initial value. It's good to know for some of the for some of the homework on this section here. Now B part. B part is how many assets will there be in 2012? So we have to evaluate the function at 12 at x equals 12, which means we plug in 12 for the x. We use a calculator. It's going to give us something like 616.8171575, rounded out to the nearest tenth. So it's going to give us $616.8 billion. That's the answer for these problems. Okay, now I believe this is the last one. Okay, for this PowerPoint. Remember that I said that when x equals 0, right? That's your initial value. So it's important because we're going to use it here. Hey guys, I mean during COVID, I remember that during COVID, we went into lockdown. I think after spring break in the year 2000. So we were covering this section here right before spring break. So right before we went to lockdown, that everything went from face to face to online. I mean, I was getting it was kind of anxious getting all the information that was going on throughout the world. So I used some of the cases at the beginning to show my students how exponential functions are used in real life. So we came out with a function with the data that we acquired. Okay, if you guys remembered, it says here a deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. This was actually true, guys, here in the United States, because I believe, like towards the end of January, early February, there were 2 cases over there in Washington State. The 2 people here in the U.S. were infected. And then by the end of April, the cases had grown to 128. So from there, I gave the example just to show students how important to use mathematics in the world. And from that scenario, we were able to more or less estimate how many people will be infected at any given month or part of the year. Okay, so here's how it goes. Here's my solution. Right, we need to find y naught, which is the initial value, and we need to find my b. The y naught here, guys, or y sub 0 is my y naught. It's called y naught, and it's called your initial value. Because the initial value, when we started the experiment, right, or the first part of the exponential function, there were 2 cases, right? So the 2 is going to be my y naught, which is my initial value. Okay. Now we're going to go all the way to the end of April. So t equals 1 corresponds to the end of February, because t equals 0 corresponds to the end of January. So t equals 1, like a month later, will be the end of February. T equals 2 corresponds to the end of March, and t equals 3 corresponds to the end of April. So at the end of April, we had 128 cases. Right, we can go from here to here, guys. Right, but I did this because most students are visual learning. Visual learners. That's why I did everything without skipping no steps. So right, so now we need to use what we know to find b. Okay, so this is my formula, right? So I need to find b in red. The y naught is equal to 2, right? So f of 3 means right, when x is 3 or when t is 3, y is 128. So I'm going to plug in the 128 for the f of t. I'm going to plug in the 2 for the y naught, and I'm going to plug in the 3 for t for the time. See, there it is. Again, this is my y, which is the f of t will be 128. I'm going to plug in 2 for y naught, which I did here in the formula. And then I'm going to plug in 3 for the t, because it was 3 months later. Now I want to solve for b. So here I'm going to divide both sides by 2. That's going to give us 128 divided by 2, which will give us what? 64 equals to b cubed. Now here's where I told my students today, because we went over this problem today in class. So I told my students to raise it to the 1/3 power, because it's the same thing as taking the cube root of both sides. By taking the cube root of both sides, you cannot put it in the calculator. That's why I told my students to raise it to the 3rd power. And here we're going to apply one of the rules that we learned, right? That we learned earlier today. When you have a power to a power, you multiply the powers. You see? So b cubed times 1/3, b cubed to the power of 1/3 will give us 3 times 1/3 will give us 1. That's why this becomes 1. So it'll be b to the 1st power equals to 4. And 64 can be entered into the calculator just the way it is, and it's going to give us 4. 64 to the 1/3 power will give us 4. Okay, now, so I found my b, I found my y naught, right? So all we do is plug into the formula. So my y naught is 2 and my b is 4. So this is a formula for part A. Okay, now for part B. For part B, right, from January to December is 11 months. So we're going to evaluate the function from part A. Evaluate the function at 11. So f of 11 equals to 2 to the 2 times 4 to the 11th power, which the result will give us 8,388,608 people will be infected by the end of the year. I believe, guys, this wasn't the case because there weren't that many cases at that time here in the U.S. But because in the U.S., guys, and also all over the world, there was intervention. For example, there was a social distance of 6 feet, hand sanitizers, washing your hands, and also there was quarantine. And so there was a lockdown. Everybody had to stay home, right? Unless, right, it was you had to go to work, right? But most of the states here in the United States, they went to lockdown for like 2 weeks, I believe. Nobody could go out. That was intervention. If not, if nature took its course, this is how many people would have probably been infected. Okay, so thank God for formulas, guys, for math and scientists that we can more or less come up with those types of functions that we can estimate exponential functions at any given day, any year, any month, any week, or any year. In this case, it was months, right? I want to thank you guys for joining me for today's Math Happy Hour. Let me take it back to the host so they can let you know what's going to take place next week. If you need my PowerPoint, send me an email and I'll send you the PowerPoint. But I believe that this workshop is recorded and is going to be there at the Tejano Visual Events. It's going to be put there. Okay, but if you want the PowerPoint, you can send me an email and I'll send it to you. If you need help, you can ask questions, or you can come see me for help, or you can ask some of the tutors. Okay, thank you very much.
Thank you, Mr. Sassi. We want to remind everybody about the presentations that are available on a YouTube playlist. It's our previously recorded sessions. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. So if you guys can please take a few minutes to fill out that survey, and before you all leave, I want to share the TVE sessions that we will have next. At 1 p.m. today in this room, back in the 1314 room, we will have a presentation on degree works with Debbie Knapp. We will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover synthetic division and complex numbers, and Math 1324 will cover solving exponential and logarithmic equations. Our 1 p.m. session next week will be a presentation on El Paso Children's Garden. Thank you all for coming in today. We hope you all have a lovely weekend. Thank you again, Mr. Sassi. And if anybody has any questions, feel free to use the chat box or your mic, and we'd be more than happy to help. We hope to see everyone again for Happy Math Hour.